Hello everyone. Today we're going to go over how to make a controller in Verilog to drive the ultrasonic sensor. So right here we have the sensor and we have our Verilog implementation on this FPGA here. So as you can see, it's not doing anything right now, but that's just because I have bad connections. If I jerk it a little bit, now it's going to start working again. Okay, yeah. So if this board was not old, it would always work, but because it's old, it sometimes works, sometimes doesn't work. But it's purely a mechanical issue because of those being bad. That's why when I just tap it, it just all of a sudden changes. Though that will not be a problem on your board if you have good connections. So yeah. Let's see if I can make it get stuck again so I can show you. Oh, it's kind of hard to make it get stuck. Okay, well, look, I'm gonna jerk this. I don't know. Okay, well, it's clearly working. So now we're gonna go over how it actually works. So first off, before we can design Verilog for it, we need to understand how the sensor works. So the sensor, to read the distance, our controller or FPGA drives this trig pulse. Oh yeah. Because this is the pin out of the part. There's a ground pin, a power pin, and then there's a trig and echo pin. The trig pin is driven by the FPGA. The echo pin is driven by the sensor. So what the FPGA is going to do, it's going to drive the trig pin high for 10 microseconds for like a little pulse. Then immediately after that, the sensor is going to send out its ultrasonic wave through its transducers, and then it's going to hit the object and bounce back. And then, so that's going to happen between times T2 and T3. Then once it's done that, the sensor is going to drive the echo pin high for an amount of time that is in direct proportion to how far away the object was. So what that means is, to detect distance, we need to have our FPGA drive the trig pulse anytime a start signal is received. And then it's going to wait some time later for the first rising edge. And then actually it's going to wait. And then immediately when the echo pin goes high, it's going to start incrementing a counter. And once we detect a falling edge on the echo pin, then we use the count as our raw distance. And we then prepare for it all to start again. So here, this is the schematic of the entire Verilog controller. So this module here is just a basic synchronizer. All it does is it takes in a huge square wave from a button and then generates a single clock cycle pulse. Then the trig pulse generator, all it does is it takes in the start pulse and generates the 10 microsecond pulse. So our synchronizer is going to receive a button press. It's going to generate a single clock cycle pulse. Then the this module is going to generate the 10 microsecond pulse into here. Then the echo pin is going to be driven high. And the echo length reader module is going to record the raw distance and output the done. And then that's going to go into a divider module, which will then go to a binary to decimal converter to then drive the result on the 7 segments. And yeah, oh, and we divide by 148 with our divider, because this echo length reader, it's going to give us a raw value, but to convert that raw value into inches, you need to divide it by 148. So yeah. So we're only going to go over the trig pulse generator and the echo length reader, because the fixed point divider, that was covered in a previous video in this playlist. There's in this playlist, once this playlist is done, there's going to be a video for an adder, for a multiplier, and a divider. So if you want to understand how that module works, check that video out. The binary to decimal and 7 segment module, that too was already covered previously, so those will not be discussed. But and the synchronizer, that's just a simple module, so we'll go over that briefly. But it's mainly this one and the overall instantiation that you'll need to understand. And as usual, the code for all of this will be provided in the video description. So yeah. So for the trig pulse generator, that's yeah. So yeah. This is all the trig pulse generator is. It's got its input for the clock, start input, trig output. So when the start signal is 1, the count gets incremented, and then when the count is not 0, we continuously count. Then only after 100 cycles does the trig go to 1, then sometime later it goes back to 0 and everything resets. So what that's going to do is it's going to have this effect. So we make a little start pulse. So we make our start pulse. It's going to generate this. And this is for 10 microseconds. And so we apply another start pulse. It's going to do the same thing. Oh, so the start pulse, it came too soon. So let's just make it come way later. So here we go. We have our module. It receives a start pulse the first time, generates a 10 microsecond pulse on the trig line. Then we apply another pulse later, and it repeats the same thing. So by applying a start signal to our trig module, we can drive the trig output. Here, let me bring it. So every time we apply a start pulse here, the trig wire to this sensor gets driven continuously. So yeah. So now let's go over the echo length reader. So the echo length reader, it's got an input for the echo and an output for the raw distance and a done. And this is the code here. Very simple. But let's look at the waveform. So when the echo pin is high, the counter is counting, and then once it goes low, we update the raw distance with the value of the counter. And then we have a done pulse happen right after. So for here, it lasted for 5 microseconds. That's why it says 500. Then here, it lasted for 10 microseconds. That's why it says 1000. And here, it lasted for 15 microseconds. That's why it lasts for 1500. 1500. And then this done pulse. So yeah. So just to summarize, well, let me get the thing. So just to summarize, the way this module works, this controller works, is that we have our stimulus, which in this schematic is a button. Press the button, the synchronizer makes a single pulse, the trig pulse generator. Then once this receives that pulse, it drives the trig line. Then this sends out its signals. Then sometime later, it'll drive the echo pin high in direct proportion to how far away the object was. Then the echo length reader is going to update the raw distance, and then sort of done pulse. So then this done pulse is then going to start a division where we're going to divide that raw distance by 148 to get a quotient. We're going to feed that quotient into the binary to decimal converter. Then we're going to feed the output of that to the 7 segments to then drive our controller. And it's important to know that in this synchronizer, like in the schematic, if we were to implement it this way, it would only drive a single pulse. In the code that you saw demonstrated, it's like this, where we apply a pulse once. So we feed in our huge square wave here, and then we get a single cycle pulse here to then trigger a start pulse generator, which continuously generates start pulses in even intervals of 70 microseconds. So yeah. So this module, this module, this module, this module, and this module are all in this block, but the synchronizer is not part of it. We just connect the start of this to like the start of that. Let me show you some other code. So yeah, this is the start pulse generator. Right here, the start pulse generator. So the start pulse generator receives a start signal from the button press, and it will continuously output a little pulse every 70 milliseconds. So that allows us to continuously have the cycle continue. So as usual, all of the code for this controller is in the description. But yeah, if you want to look more, oh yeah, and then the synchronizer just takes in a pulse in, makes a pulse out. And the pulse in's a big
Square wave, the pulse out is a single cycle pulse that gets inserted on the falling edge. Kind of like this. Let me show you. So synchronizer. I'm taking a square wave like this, and then its output. I'll draw it underneath the output. It's just going to be that. That's all the synchronizer does. So the synchronizer just does this. Takes the huge input from the button press, makes a single pulse by detecting the falling edge. So then we can trigger events on the falling edge. But anyway, as usual, this code is going to be provided in the video description. So you are free to take it and incorporate it in your own projects or modify it however you want. But yeah, as you can clearly see, it is working pretty good. So yeah, it is doing its thing. All right. Oh wait, oh, you guys didn't even see that. Okay, shoot. Okay, well, here. So yeah, as you can clearly see, it is doing its thing. And you can use this on anything you want. Later, in later videos, we're going to go over how to make a PID controller to balance a ball and a beam. And this sensor might be used in that. Or we might use the other sensor that we're going to discuss later in a future video. That's all for now.